we will proceed on practical task number 4. Practical task number 4 is about the current chapter. Okay, the current chapter we are going to use the same apparatus actually. So this one is to study the relationship between friction. So you have learned regarding enlargement, contraction, and the last one will be the friction factor. So we are going to correlate with Reynolds number. So in previous practical tasks, you learn regarding this Reynolds number. So please watch the YouTube so that you have better understanding. Basically, Reynolds number will tell you whether this flow will be a transitional flow, laminar flow, or a turbulent flow. Okay. So also, we'll give you the result already. So it will be the same like previous. You have Q, okay, Q value here, and you have the pressure difference denotes from the manometer, and then the X value here, delta H, manometer levels, okay, the water level. So you need to try to obtain what is the F value lah, okay, friction value there. So I will try to show to you the video, audio, any audio. You play it first, right? Can you hear anything?
No, sir.
No, it's all right. Okay, so please have a look on this one. So the objective have been mentioned to you already previously. So later I will provide you the YouTube link for this one, then you can listen more lah, so they have a better understanding. So this one will be the Rutten pipe that we will be the sample of object here lah. So during that pipeline from first point to the end point there, how much friction you will have there. Okay, PVC pipe. So the digital meter here will be the same flow rate. Flow rate. Liter per minute here, 1.79 liter per minute currently. The differential pressure show that 0.2 kilopascal. For more accurate reading, you can take it out from this meter here, see 0.2319. So over here, you will have a more detailed reading of the difference of pressure. So delta H, okay, delta H is given by this water level heights, difference of heights here. So 0.1 will be here, then the other one will be the 0.2, 0.2. So we are going to minus the heights level. Okay, so actually this experiment we can have another setup which will be enlargement. So if you enlarge your pipeline, then what will actually happen? But the subject of interest here will be the friction losses currently. Then suddenly this one contraction happen again. That's mean from a bigger diameter, we shrink it into a smaller diameter. Okay, you can obtain all the value from the table from here. I hope you can watch this YouTube again later, because the explanation might be more comprehensive. Okay, so you need to fill in this table. Okay, you fill in this table. So as usual, they give you the flow rate. Then you need to obtain the velocity. Okay, using the diameter given here. Diameter of the PVC pipe now will be 8 millimeters. So I think you are familiar with the calculation already, right? Okay, Q equals to AV, yeah? Q equals to AV. So diameter 28 mm. Q will be liter over minute. So like previously, divided by 1000, then you divide by 60 again to obtain the Q value here. So you are able to calculate V in meter over second. The next one, pressure in the digital meter there is given to you 0.2319 just now, right? So over here, the Reynolds number will be denoted by this value here. Reynolds number, right? Reynolds number. So please try to obtain the Reynolds number, okay, by using this calculation. Velocity put in here, diameter put in here, the viscosity, kinematic viscosity, you will have this value, okay? 8.9 times 10 power of negative 4 is a fixed value at 25 degrees C, yeah, ambient temperature. So using this value placed inside here, then you're able to obtain the Reynolds number. Yeah, Reynolds number. Okay, last one will be based on the H value here. This one will be the ratio of pipeline here. We try to obtain so that you can put in at here. So what's the value that you can put in from here? Here. Okay. The calculation will be like this. Okay, because the value of E here is fixed for PVC. Depends on the material, it's fixed at 0.015. So over D here, 28. Okay, from the graph here, you are going to have a look of what's your Reynolds number. For example, your Reynolds number is 2 times 10 power of 4 lah. Okay, power of 4. You drag one line up here, and then you try to come up if your value of E over D here, for example, is 0.008. So you draw another line here. So once it meet at certain point here, right? Meet at certain point here. So over here, what's the F value here? What's the F value? So maybe this one is close to 0.04 F value. So you are going to obtain the F value, coefficient of friction, from this graph itself. From the graph itself. Okay. So that will be the way to obtain this F value actually. So far, do you have any questions? So try to come up with the value. I will give you this lab sheet, this lab sheet, and please refer to the video so that you're able to find out friction F with Reynolds number, the coloration wise.